A tank from the 1950s is still fighting wars today. How is that even possible? Was the M60 Patton one of the greatest American tanks ever built, or one of the most overrated? In this video, you'll discover why the United States rushed to build it, the engineering decision that kept it alive for more than half a century, the experimental version that almost became a complete disaster, and the hidden weakness that real combat exposed to the world. And by the end, you'll understand why so many armies refused to retire the M60, even after the Abrams entered service. If you're interested in tanks, secret military projects, and forgotten war machines, be sure to subscribe to the channel and turn on notifications. There are many more fascinating stories ahead. Enjoy the video, and let's continue. Some tanks achieve legendary status through a single decisive victory, while others become icons due to groundbreaking design or unmatched performance. The M60 Patton, however, stands apart because it defied the passage of time. While its contemporaries have long been relegated to museums, the M60 has remained a staple in military arsenals across the globe, enduring decades of combat and constant evolution. It is a testament to engineering longevity that a design born in the late 1950s remains a relevant force today. There is a persistent misconception that the M60 was merely a Cold War stopgap that vanished the moment the Abrams arrived. In reality, the M60's path was far more complex. After 3 decades of service with the US military, it found a second life abroad. Some nations acquired it as a reliable, cost-effective main battle tank, while others invested in massive upgrades, keeping the platform operational for over 60 years. The M60 is not a relic of a bygone era. It is a survivor that has witnessed multiple generations of armored warfare. What began as a platform relying on simple optical sights has been transformed through modern upgrades, integrating thermal imaging, digital fire control systems, and advanced communication suites. It is a unique case of a fundamental design successfully adapting to the shifting demands of the modern battlefield. The secret to such longevity cannot be explained by a single successful characteristic. In its base version, the M60 adopted the classic layout of a main battle tank with a crew of 4: driver, gunner, loader, and commander. American engineers refused to use an automatic loader at the time, opting instead for a well-trained loader. This decision allowed for maintaining high practical fire rates even during prolonged combat, while the turret design remained simpler and easier to maintain. An equally important feature was the overall architecture of the vehicle. The combat weight of the first production M60 was approximately 47 tons. By the standards of its time, this was a fairly heavy tank, but the weight was distributed in such a way as to maintain acceptable mobility while ensuring serious protection for the crew. The hull had a traditional welded design, while the turret was made by integral casting. This combination of technologies allowed for complex shapes of armored parts without excessively increasing the number of welded joints, which were often considered potentially more vulnerable points. Special attention was paid by the designers to the frontal projection. The upper front hull plate had a significant angle of inclination, due to which the reduced thickness of the protection noticeably increased compared to the actual thickness of the armor plate. The cast turret also received rounded shapes, which increased the probability of ricochet when hit by shells. Even then, engineers perfectly understood that geometry sometimes protects no worse than additional millimeters of steel. The armament also immediately placed the new machine among the most powerful Western tanks of its time. The main weapon was a British-designed 105mm rifled gun, manufactured in the USA under license. It was this weapon that would later become a kind of standard for a multitude of Western tanks. The ammunition was located inside the hull and turret in such a way as to ensure the most convenient work for the loader and reduce the time for preparing the next shot. This decision alone noticeably influenced the combat capabilities of the machine. But the most surprising thing is something else. Over decades of service, the M60 has practically never remained unchanged. It was constantly improved. Engines were changed, sights were perfected. Laser rangefinders, new weapon stabilization systems, modern thermal imagers, and digital ballistic computers appeared. Some vehicles received reactive armor, others were equipped with completely new power plants, and others were so deeply modernized that they were difficult to recognize externally. At the same time, the basis of all these projects remained the design developed back in the middle of the last century. Such longevity inevitably raises the question, why exactly did the M60 prove to be such a successful foundation for constant upgrades, whereas many of its contemporaries disappeared much faster? After all, history knows many machines with impressive characteristics that turned out to be too expensive, too complex, or simply became obsolete quickly. With the M60, the exact opposite happened. It proved again and again that it was capable of adapting to the new requirements of the battlefield. But such stories do not happen by accident. Behind every successful tank, there is almost always a serious reason that forced the designers to abandon previous solutions and look for a completely new path. And to understand why the M60 appeared at all, and why its design turned out to be so durable, it is necessary to go back to the late 50s, to the moment when the American command suddenly realized that the previous main tank was ceasing to meet the new reality. By the end of the 50s, the United States suddenly faced a problem that they had recently considered unlikely. It seemed that the M60 Patton fully met the requirements of the Army. It was already in service, was produced in large series, and was constantly being improved. However, the development of armored vehicles in the Soviet Union was happening so fast that American analysts began to seriously fear losing their technological advantage. New Soviet machines received more powerful guns, improved armor protection, and gradually changed the idea of what a modern main battle tank should be. It became obvious that another small modernization was no longer enough. Especially serious concerns were caused by the spread of the T-54 and T-55 tank families. Their relatively low silhouette made detection on the battlefield difficult, and the 100mm rifled gun posed a serious threat to almost any Western machine of that period. Additional concern was caused by the scale of production. American specialists understood that the potential enemy was betting not only on the quality of individual samples, but also on the ability to quickly deploy a huge number of armored vehicles. This meant that the future American tank had to outperform the enemy not only in individual characteristics, but also possess a significant reserve for further development. That is why the new project was initially conceived not as a completely revolutionary machine, but as a deep rethinking of an already existing design. This approach allowed for significantly shortening development times. The engineers kept the proven general layout, but practically every important unit underwent redesign. Especially much attention was paid to protection, armament, and the power plant. The main task was to create a tank that would be able to confidently resist new threats not only today, but also many years later. Work proceeded under constant pressure from the military leadership. Designers had to look for a balance between production cost, technical capabilities of the industry, and the Army's requirements. Any decision was evaluated according to several parameters at once. Thicker armor increased the survivability of the machine, but simultaneously increased the weight. A more powerful engine improved dynamics. However, fuel consumption increased and technical maintenance became more complicated. Each new system inevitably brought along a whole chain of engineering compromises. One of the first fundamental decisions was the final abandonment of the further development of the 90mm armament. The experience of numerous tests showed that the potential of such guns was gradually being exhausted. To confidently defeat promising Soviet tanks, a more powerful gun with significantly better ballistic characteristics was required.
That is why the future M60 was immediately designed around a new 105mm rifled gun, capable of using significantly more effective armor-piercing discarding sabot and shaped charge ammunition. Such a decision provided a serious reserve for the modernization of armament for many years ahead. Equally important was the change in the hull design. The engineers increased the angle of the upper front plate, due to which the effectiveness of protection increased without a sharp increase in weight. At the same time, they redesigned the internal layout, improving the placement of equipment and ammunition. Even small changes in the internal space allowed for making the maintenance of units more convenient and increasing the general repairability of the machine in field conditions. For an army counting on a possible large-scale conflict in Europe, such details were of enormous importance. However, even after the approval of the general concept, no one could guarantee success.
On paper, the new tank looked quite promising, but numerous tests lay ahead. It was they that had to show whether the engineers managed to create a new generation machine or if the military would see only another modernization of the old M48 with minor improvements. The answer turned out to be much more interesting. Externally, the new tank is indeed easy to confuse with its predecessor. If one puts the M48 and the early M60 side by side, an unprepared person might well decide that the differences between them are minimal. Familiar outlines of the hull, a characteristic cast turret, and a classic layout were preserved. But it was this similarity that played a curious joke on the machine. For many decades, people have considered the M60 to be just another modernization of the previous generation, although, in fact, completely different engineering solutions were hidden inside. The first serious difference was in the front part of the hull.
The new upper front plate had a more rational angle of inclination and was made of a solid rolled armor plate. Its nominal thickness was about 110 millimeters. However, thanks to the geometry, the reduced resistance increased significantly. Such a solution allowed for more effectively resisting armor-piercing shells without a significant increase in the total weight of the machine. The lower front part had less protection, so it was the upper part of the hull that American engineers considered as the main barrier against enemy fire. The turret also underwent serious processing. It retained the cast design, but received a more massive front part with increased armor thickness. In the most protected sections of the frontal projection, it reached over 200 millimeters. The rounded shape not only increased the probability of ricochet, but also allowed for rationally distributing the thickness of the metal across different sections of the surface.
At the same time, the sides of the turret remained noticeably thinner. This decision was explained simply. The probability of being hit in the frontal projection on the battlefield was considered significantly higher. The internal space also changed. The driver was located in the front part of the hull, exactly in the center, which provided a good view through several periscopic observation devices. In the turret, on the left was the gunner, on the right was the loader, and behind them was the commander. Such an arrangement allowed each crew member to perform their tasks as efficiently as possible, and practically not interfere with the others during intense fire. In addition, the commander received his own commander's cupola with all-round visibility, which significantly facilitated the search for targets. Special attention was paid to ease of maintenance.
Access to the main units became easier, and many elements of the design were designed with the expectation of quick replacement in field conditions. The American Army understood perfectly well that in the conditions of a large conflict, the speed of repair is sometimes no less important than the thickness of the armor. That is why engineers strove to simplify the maintenance of the engine, transmission, and individual units of the suspension as much as possible. The suspension also changed. The tank retained the proven torsion bar system with 6 road wheels on each side. However, many elements were reinforced, taking into account the increased weight of the machine. Hydraulic shock absorbers were installed on the most heavily loaded nodes of the suspension, which reduced the rocking of the hull when moving on rough terrain. Thanks to this, the crew felt more confident, and the accuracy of firing on the move gradually approached the requirements of the new generation of armored vehicles. But even all these changes were just preparation for the main advantage of the new tank. It was the armament that had to finally prove that there was a completely different machine in front of the army, capable of fighting the most dangerous Soviet tanks of its time. When engineers started creating the new armament for the M60, they understood perfectly well that another minor enhancement would not change anything. The potential of the 90mm guns was practically exhausted. Their armor penetration was gradually ceasing to meet the requirements of the future battlefield, and the appearance of more and more protected Soviet tanks forced the search for a fundamentally new solution. That is why the choice fell on the British L7 rifled gun, which the Americans began to produce under license under the designation M68. Subsequently, this weapon would become one of the most successful tank weapons of the second half of the 20th century. The barrel, 52 calibers long, provided a high initial velocity for most ammunition and excellent accuracy at long distances. For its time, the M68 was considered almost a standard among Western tank guns. It used unitary shots, which noticeably facilitated the work of the loader and allowed maintaining a practical rate of fire of about 6 to 8 rounds per minute. The ammunition load was 63 shots, distributed between the hull and the turret in such a way that the most sought-after ammunition was as close as possible to the loader's workplace. The range of ammunition was constantly expanding. Initially, the main role was played by armor-piercing discarding sabot shells, shaped charge ammunition, and high-explosive fragmentation shots.
Later, more advanced sabot shells with improved cores appeared, allowing one to fight already new generations of Soviet tanks. The versatility of the armament was considered one of the main advantages of the M60. The same tank could effectively work against armored vehicles, fortifications, or enemy manpower, without requiring the installation of specialized armament. The main gun was supplemented by a coaxial 7.62mm machine gun, intended for hitting light targets and zeroing. On the commander's cupola, a 12.7mm heavy machine gun was placed, allowing one to fight low-flying air targets and unarmored vehicles. In the first years of service, such a set of armament was considered optimal for a main battle tank of a Western army. No less serious attention was paid to the guidance system. The gunner received a new telescopic sight with high magnification, allowing for confidently detecting targets at significant distances. The vertical armament stabilizer noticeably increased the probability of a precise hit when moving on rough terrain, although full-fledged firing at high speed still remained a difficult task. Even then, American specialists understood that in the future it would be fire control systems that would determine the effectiveness of the tank, no less than the power of the gun itself. However, even the most perfect armament does not guarantee an advantage if the machine is not capable of quickly changing positions and acting confidently on any terrain. That is why, in parallel with the creation of the new gun, engineers were solving no less a complex task: how to maintain decent mobility with the constantly increasing weight of the tank. The heart of the M60 was the 12-cylinder, air-cooled Continental AVDS-1790 diesel engine. Its power was 750 horsepower, which for the end of the 50s was considered a very decent indicator. American designers deliberately chose the diesel power plant. Compared to the gasoline engines of previous machines, it was characterized by lower fuel consumption, increased range, and significantly reduced the probability of fire in case of damage to the engine compartment. Together with the engine worked the Allison CD 850 hydromechanical transmission with 2 forward and 1 reverse gear. Despite the relatively simple design, it provided smooth shifting and significantly facilitated the control of the heavy machine. Even an inexperienced driver could learn the basic driving techniques quite quickly, which was of great importance for the mass training of crews. The maximum speed on the highway reached about 48 kilometers per hour. On rough terrain, the indicators were, naturally, significantly lower. However, it was there that the merits of a well-tuned suspension manifested. Wide tracks reduced the specific ground pressure, allowing the machine to move more confidently on soft soil. The fuel supply provided a range of about 500 kilometers on a good road, thanks to which units could operate at a significant distance from supply points. At the same time, the increased weight inevitably created new problems. The load on the running gear increased, individual elements of the suspension wore out faster, and engine maintenance required high qualifications of technical personnel. The air cooling system worked well in most conditions, but when operated in a very hot climate, it required especially careful control of the state of the power plant. The military quickly became convinced that the reliability of the tank largely depends not only on the quality of the design, but also on competent maintenance. Despite these features, the M60 earned the reputation of a fairly unpretentious machine. Its engine was characterized by a long service life, the transmission successfully withstood long marches, and most nodes were repaired without the use of complex equipment.
It was thanks to this combination of characteristics that the tank turned out to be attractive not only for the US Army, but also for numerous foreign customers who needed reliable equipment with relatively low operating costs. However, engineers understood perfectly well that even a successful design cannot remain unchanged for decades. While some M60s were just entering the troops, specialists were already working on their next generation, and very soon it turned out that the potential of this platform was significantly higher than was assumed at the very beginning. The first years of operation convinced the American command of the correctness of the chosen concept, but at the same time revealed many directions for further improvement. Instead of developing a completely new tank, it was decided to gradually modernize the already existing machine. Such an approach allowed for significantly saving funds, not stopping production, and simultaneously introducing the most modern technologies. That is why the history of the M60 effectively turned into a history of continuous evolution. The first major stage was the M60A1 modification. It received a completely new turret of increased volume, with a more rational geometry of armor. The reinforced frontal part provided better protection for the crew and the internal space became more convenient for the work of the commander and loader. At the same time, the volume of the fighting compartment increased, which had a positive effect on the speed of performing most operations during battle. It was the M60A1 version that soon became the most mass-produced among all representatives of the family. The next stage turned out to be much bolder. The M60A2 received a completely new, low-profile turret and unusual armament. Instead of the familiar rifled gun, the tank was equipped with a 152mm gun launcher. It could fire both ordinary shells and MGM-51 Shillelagh-guided anti-tank missiles. On paper, such a scheme looked revolutionary. It was assumed that the tank would be able to hit targets at significantly greater distances than any existing opponents. In practice, everything turned out to be significantly more complicated. Complex electronics required constant maintenance, guided missiles were very expensive, and the reliability of the complex left much to be desired. In addition, the rate of fire noticeably decreased, and the work of the crew became more complicated. As a result, the M60A2 gained a controversial reputation and served significantly less than the rest of the family's representatives. Later, the American tankers themselves gave this modification a very ironic nickname, hinting at the excessive complexity of the design. A completely different fate awaited the M60A3.
It was this version that became the pinnacle of the development of the entire family. The tank received a modern laser rangefinder, allowing for almost instantaneously determining the distance to the target with high accuracy. An analog ballistic computer automatically accounted for many parameters before the shot, including range, type of ammunition, and external conditions. The commander and gunner received significantly more advanced observation devices, and later vehicles were equipped with thermal imaging systems, allowing for detecting the enemy at night, in smoke, and in poor visibility. At the same time, they modernized the armament stabilizer, increased the reliability of electrical equipment, improved communication means, and improved the general ergonomics of the crew's workplaces. All these changes did not catch the eye at the first glance at the tank, but it was they that sharply increased the probability of the first accurate hit.
And in a modern tank battle, it was the first shot that very often became decisive. Gradually, it became obvious that the M60 was capable of developing for significantly longer than its creators had expected, but no tests and modernizations could finally prove the value of the machine. The real assessment of any tank is always given only by the real battlefield, and very soon the M60 had the opportunity to show how successful all the decisions of the American engineers had turned out to be. The first serious tests of the M60 were passed not in Europe, where a possible clash with the armies of the Warsaw Pact was expected, but in the Middle East. It was there that American tanks were supplied in large quantities to US allies. During the Yom Kippur War, Israeli crews used the M60 in extremely difficult conditions, where they had to act against a well-prepared enemy saturated with anti-tank weapons. The machine quickly proved that it was capable of withstanding intense operation.
However, something else was revealed. The high silhouette made it easier to detect the tank on open terrain, and the hull sides with a thickness of about 70mm remained significantly less protected than the frontal projection. In conditions of flank attacks, this became a serious problem. It was then that competent tactics of using the terrain's folds and firing mainly from closed positions acquired special importance. Despite individual losses, the crews highly appreciated the capabilities of the main armament. The M68 gun confidently hit most of the Soviet tanks encountered at real combat distances. Sighting devices allowed for effectively working at distances of over 2 kilometers, and a large selection of ammunition provided the opportunity to quickly adapt to the changing situation. But at the same time, one more drawback manifested itself. The ammunition was located without modern isolated niches with blowout panels.
In case of armor penetration, there was a risk of ammunition ignition inside the fighting compartment, which significantly reduced the crew's chances of saving the machine. It was this experience that would later have a serious influence on the design of the next generations of Western tanks. The combat experience gained became a real textbook for American engineers. They saw that even a powerful gun and reliable armor do not guarantee superiority if the enemy competently uses the terrain, anti-tank complexes, and ambush tactics. After analyzing the first conflicts, a new wave of modernization began, aimed not so much at strengthening firepower as at increasing the tank's survivability and the efficiency of the crew's work. It was then that it became finally clear that a modern tank represents a complex system where every technical detail directly affects the result of the battle. Subsequent wars confirmed this conclusion even more convincingly.
The M60 repeatedly clashed with tanks of the Soviet school, the T-54, T-55, T-62, and more modern machines. These encounters showed that the outcome of a duel is far from always determined by passport characteristics. A huge role was played by the level of training of the crew, the organization of unit interaction, and the quality of reconnaissance. Where commanders competently used the advantages of the M60, its capabilities were revealed as fully as possible. But where tanks acted without support, even good technical characteristics could no longer compensate for tactical mistakes.